We're on lesson 8 of chapter 10, which is permutations. First, we're going to use the fundamental counting principle to solve. Then we're going to use factorials to find the number of permutations. Then we're going to use factorials to solve combinations. First, let's focus on the difference between combinations and permutations. With combinations, they are the grouping of objects or events when the order does not matter. With permutations, it's the arrangement of objects or events when the order is important. This is the major difference. So for example, with permutations, if you are making a 4-digit password using A, B, C, and D, how many different passwords can you create? Well, with permutations, the order is important, as with passwords too. You have to type the password in the right order. So you literally have to start writing out all the different passwords that start with A. A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B. Then we could go with A, D, B, C, A, D, C, B. Then we could try the ones that start with B and kind of do that same thing. And then we could do the ones that start with C and the ones that start with D. Eventually you're going to run out, then you can count how many you've made. And you notice this does take a long time. It is useful to know how to do this, but we're going to teach you other ways to solve these permutations as well. First, we're going to use the fundamental counting principle to solve. And here's the idea of a fundamental counting principle with an example. We have 3 students that have agreed to serve in leadership positions in the Spanish club. In how many different ways can the students fill the positions of president, vice president, and secretary? So if we're using this counting principle, we're looking at the position of president first. If we have 3 students, all 3 of them could serve as president. Once we've picked a president, though, that means we only have 2 students left. So if we're going to pick a vice president, we only have 2 to choose from. Now that we've chosen the vice president, we're down to 1 student, meaning that only 1 person could become the secretary. And then to solve for these, we'd have to multiply the 3 options for president times the 2 options for vice president times the 1 option for secretary. And this means that there are 6 different ways that these 3 students could become president, vice president, and secretary. What we've just done here is actually a factorial. A factorial of a whole number is the product of all the whole numbers except 0 that are less than or equal to that number. So the factorial of 8 with this exclamation point here is multiplying 8 and then counting down all the way to 1 and multiplying all these numbers in the meantime. It equals 40,320. We did a factorial with 3 because there were 3 students to choose from. That's why we use that. If there were 6 students to choose from, we'd do 6 for the first position, then 5, 4, 3, 2, and 1 all the way down. Let's try that with a couple other examples. There are 9 players in a baseball lineup. How many different batting orders are possible for these 9 players? So in a batting lineup, you have someone bat first. Well, if the coach is going to pick someone to do that, he has 9 players to choose from. So that could be 9 different people. Now that he's picking his second spot, he has only 8 people to choose from because one of them is batting first. So that means 8. For the third spot, that leaves 7 people to choose from. For the fourth, 6. For the fifth, 5. For the sixth, 4 people to choose from. For the 7th spot, 3. For the 8th spot, now he's down to 2 people. And that means he'll be down just to 1 person for that 9th spot. So how many different possible ways can he make the batting order? You're going to be surprised how big this number is. He has 362,880 different ways to make this batting order. How about if there's more people to choose from than they have spots? Well, let's think about it this way. If there are 12 people on a team, but only 9 can bat, how many different batting orders can you do then? Well, for that first batting spot, the coach now can choose between 12 people. So there's 12 total options. For that second batting spot then, he has 11. After that, he has 10. Now that there's 3 people picked, for the 4th spot it'll be 9. And then there's 8 people for the 5th spot. For the 6th spot, he has 7 to choose from. For the 7th spot, he has 6. For the 8th spot, there's 5 people. And there's 4 people left to choose from for the 9th spot. 3 people have to sit the bench. I have to stop here though because there's only 9 spots to fill. So once I get to 9, I have to stop counting down. So if I multiply these across, that's how many choices the coach has for his starting lineup with 12 players. And let's hope the coach has made up his mind because he has over 79,833,600 total choices or lineups that he could choose from. It sounds like an incredible amount, but any of those 12 players could be batting in any of these 12 spots. Now we have a basketball example. There are 8 players on a basketball team, but only 5 can start. How many different starting lineups, point guard, shooting guard, small forward, power forward, and center, can there be for the 8 players? So don't mind that typo. So there's 8 players, but there's only 5 spots. So for that first spot, the point guard spot, he could choose any of those 8 players, meaning that there's 8 people to choose from for the point guard spot. After that's picked, now we're looking at shooting guard. Well, one of them is playing point guard, so that means that there's 7 people to choose from for shooting guard. For small forward, that makes 6. For power forward, that makes 5. And then for center, that makes 4. And that's where I have to stop because there's only 5 spots. That means 3 people have to sit the bench. If I do 8 times 7 times 6 times 5 times 4, that gives me an answer of 6720 or 6,720. That's how many permutations or different ways that he could arrange the starting lineup. We can also use these factorials to solve combinations. If you remember earlier here, combinations, the order does not matter. You can group it in any specific order. So in this case, there are 6 different condiments to put on a burger, but Cassie only wants 3 condiments. So how many different combinations of condiments can Cassie put on her burger? If we were going to solve this using a table or a tree, this would take us a very, very long time. Mostly because there's a combination of 3, and that makes it more difficult. Well, we actually have a formula that we could use to solve this. The factorial of n over the factorial of n minus k, so the difference of n and k, times the factorial of k. Well, what are n and k? Well, n is the total number to choose from. K is the total number in the group that you're making. So Cassie, for example, can choose from 6 different condiments, and she wants 3 in the group. So if we're using that formula, we have the factorial of n, which would be 6, so 6 factorial over n minus k, so n is 6, minus k is number in the group, so minus 3, the factorial of that, times the factorial of 3. So if we're going to write this out here, we have the factorial of 6 over 6 minus 3 is 3, so the factorial of 3 times the factorial of 3. Let's actually write that out. We have 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, which would be our first factorial, times 3 times 2 times 1 again. 6 times 5 times 4 times 3 times 2 times 1 equals 720. 3 times 2 times 1 times 3 times 2 times 1 equals 36. 720 divided by 36, well, that equals 20. So there are 20 total combinations that she could choose to put on her burger from these 6 different condiments with 3 in a group. Now we have this example. Steve was fishing in a lake with 8 different types of fish, and he caught 4 of them. How many different combinations of fish could Steve catch? So using our formula here, the factorial of n, so n is the number that we can choose from. He has 8 total types of fish to catch, so we'd have a permutation of 8. Now it's over n minus k. Well, n was 8, minus k is the total number in the group. He can catch 4 in his group. Factorial of that. And then the number in his group was 4, so we'd have the factorial of 4. Running that out, we'd have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 minus 4 is 4, so the factorial of 4. 4 times 3 times 2 times 1 times another factorial of 4. Multiplying that across, we have 40,320 over 576. And that's going to give us an answer of 70, so 70 total combinations. So by using this formula, we saved ourselves a whole lot of time instead of drawing these out in a table or a tree, which really would have taken us a really long time.